Good morning, everyone. Welcome to my classes. In this session, we are going to learn about isothermal process. So, isothermal process, iso means same, thermal means temperature. The process which occurs at same temperature. In this process, what is constant? Temperature is constant. Temperature is constant. That means T initial is equal to T final, then delta T is equal to T final minus T initial, which is equal to 0. So delta T is equal to 0. Okay. When delta T is equal to 0, we know the formula for delta U. Delta U is equal to NCV delta T. N is number of moles. Next, Cv is heat capacity at constant volume. Delta T is change in the temperature. So now N Cv delta T is equal to 0. So when delta T is equal to 0, NCV into 0 gives you 0. That means delta U is equal to 0 in isothermal process. In isothermal process, delta U is equal to 0. So according to first law of thermodynamics, FLT, first law of thermodynamics, we know formula that is delta U is equal to Q plus W. When delta U is equal to 0, 0 is equal to Q plus W. Then we can write Q is equal to minus W. Q is equal to minus W means, so let us take a gas enclosed in a cylinder, right? This is considered to be a system. Work done is negative and Q is positive. Q positive means heat is absorbed by the system. Q positive. Q positive means heat energy absorbed by the system. So here delta U is equal to 0 in isothermal process. That means there is no change in the internal energy. Whatever the heat energy is absorbed by the system, that is used to do work by the system. Work done by the system is given according to sign convention. Work done by the system is taken as negative. According to sign convention, heat absorbed by the system is taken as positive. Okay. So from this, what did we understand is whatever the heat is absorbed by the system, that is used by the system to do work. Then another one also we can write Q is equal to minus Q is equal to W. The same expression can be written in this way. Minus comes this side, right? Now Q is negative and work done is positive. That means, see, let us take Q is negative. Q negative means work done positive. Work done positive means work is done on the system. Work is done on the system. When work is done on the system, work done is taken as positive. Work done is taken as positive. Delta U is equal to 0. There is no change in the internal energy. So whatever the work is done on the system, that is released as heat. That is released as heat. So when heat is released from the system, it is taken as a negative. So from first law of thermodynamics, delta U is equal to Q plus W. Delta U is equal to 0. Right? Next, coming to delta H. So delta H is equal to, we know the formula, delta U plus NR delta T. NR delta T. Right? Now delta T is equal to 0. Delta U is also equal to 0. Then what you can write, delta H is equal to delta U is 0 plus NR delta T. Delta T is also 0. So delta H is also equal to 0 in isothermal process. So in isothermal process, delta H is also equal to 0. What is delta H? Enthalpy, change in enthalpy. The change in enthalpy or enthalpy change is called as delta H. Internal energy is 0 and enthalpy change is also equal to 0. So in another way also we can write delta H is equal to NCP delta T. N is number of moles, Cp is heat capacity at constant pressure. Again, delta T is equal to 0 according to isothermal process. Then again you write NCP into 0, that is equal to 0. So delta H is equal to 0 and delta U is also equal to 0 according to first law of that is in isothermal process. Okay. So isothermal process, we have studied previously isothermal process, Boyle's law. Boyle's law. What is Boyle's law? According to Boyle's law, PV is equal to constant. PV is equal to constant for a particular gas. For a particular gas, P initial, V initial is equal to P final, V final. So Boyle's law is described as the volume of a certain amount of gas is inversely proportional to pressure at constant temperature. T is constant here. That is what we are speaking about. When temperature is constant, that is what process? Isothermal process. So from this P initial, V initial is equal to P final, V final, I can write it as, okay, I can write as V final by V initial is equal to P initial by P final. Okay. So if you draw a graph for Boyle's law, what do you get? This is the graph. Let us draw the graph. So we are drawing graph between P and V, right? When a graph is drawn between P and V, we get a graph like this, rectangular hyperbola. Rectangular hyperbola, right? So this represents the graph between P and V at constant temperature, rectangular hyperbola. If you want the slope for this graph, when you want to find the slope, first of all we have to draw a tangent to this graph. So when you are drawing a tangent, so this is a tangent, straight line drawn, okay. Tangent. So where it is intersecting the graph, let it be P0 and V0, right? The angle made by this tangent on the x-axis is equal to theta, and tan theta is equal to slope. Slope of the graph can be obtained by tan theta, and theta is the angle made by this tangent to this graph, tangent with the x-axis, volume axis, right? So tan theta can also be represented as m. This can also be represented as dy by dx. Change on y-axis by change on x-axis. Okay. So what is y-axis taken here? Pressure. Pressure is taken on y-axis, and what is taken on x-axis? Volume is taken on x-axis. Then here slope will be equal to m is equal to dp by dv. Now only we have studied that PV is equal to constant. If PV is equal to constant, d into PV will be equal to 0. Then differentiating P into V, then what you get? P into dV plus V into dP will be equal to 0. Then P into dV is equal to V into dP. Then dP by dV will be equal to minus P by D. P by V. Okay. So P into dV, if this comes right side, then we get minus V into dP. dP by dV gives you minus P by V. Okay. So dP by dV is slope. Now only we have discussed that dP by dV is the slope. What does this negative represents? Minus represents that the slope is negative. So what does represent? Minus represents that the slope is what? Negative. Minus represents slope, negative slope. Slope, negative slope. Okay. So isothermal process. Next, coming to isothermal reversible process. What is that? Isothermal reversible process. So reversible process means it can be expansion. It can be expansion or compression. This isothermal reversible process. What is reversible process? Already we have studied. What is reversible process? The process in which if a small reversible change occurs, the process can be reversed. Quasi-static process, and that is called as a reversible process. When a small reversible, say for example, let us take this is gas enclosed in the cylinder. Now P external compression, let us take compression here. We are compressing it. By placing a small granule, sand granule on it. It moves down. A small compression happens here. A very small compression happens. If you reverse the change, then automatically the process reverses. If a small change is, reversible change is brought to it, automatically the process is reversed. Such process is called as a reversible process. In this reversible process, let us take compression. What is that? Compression. Compression means external pressure is greater than internal pressure. So P external is greater, because when P external is greater, then only it can push the piston into the cylinder. So P internal, or we can say that P gas, pressure exerted by the gas, plus dP. dP means very small pressure. Infinite amount of pressure. Infinite means very small here. Infinite can be very large, infinite can be very small. Here we are speaking that it is very small pressure. Infinite small pressure. Okay. When coming to expansion, what is that? Expansion. Expansion means pressure inside the gas must be greater. Then what you can write? P external is equal to pressure of the gas minus dP. So what does this represent? This represents that pressure exerted by gas is greater than external pressure. Overall, in this process, whether it is expansion or compression, we can write that P external is equal to pressure of the gas plus or minus dP. Plus dP represents that compression, minus dP represents that it is expansion. Overall, for compression or expansion, we can write that P external is equal to internal pressure of the gas plus or minus a small change in the a small amount of pressure, infinite amount of pressure. If you want to calculate the work done for this, so work done, so dW, very small work done, infinite amount of work done for one step, if you speak, minus P external into dV. Okay, we already studied that for mechanical work the formula is W is equal to P external into delta V. Here a very small amount of work is done by the change of very small volume. dV is infinite amount of volume changed, infinite amount of volume changed, dV, infinite amount of work done. So for the whole process, if you want to calculate the work done, then what you need to do, you have to integrate all those small works, adding all the small works. Addition of all those small infinite amount of works can be written as integration. Integration is represented by this. So integrating all the small works, integration of dW is equal to integration of minus P external into dV. And already we have studied that what is P external. P external is pressure inside the gas or pressure of the gas plus or minus dP. So you can write minus pressure of the gas plus or minus dP into dV. Okay, so then what you get, minus P gas into dV plus or minus dP into dV. So integration of small infinite amount of pressure and infinite amount of V, this multiplication, so this becomes very smaller. Infinite amount of P into infinite amount of V will be again very small, so that can be neglected. Then finally you can write it as integration of P gas into dV. So pressure of the gas, taking the gas here, an ideal gas, what is that? Ideal gas, considering it as ideal gas, P is equal to P is equal to nRT by V. We have already studied according to ideal gas equation. Then that is equal to integration of minus nRT by V into dV, work done. So when you are adding small amount of works, you will get complete work. Okay, so work done. Now let us so work done is equal to constant. Let us separate the constants. So minus nRT, then integration of dV by V from V initial to V final. Then what do you get? Minus nRT, integration of dV by V gives you log V. Log V limits V initial to V final. Then what do you get? Minus nRT, ln means natural log, ln V final minus ln V initial, ln means natural log, that is equal to minus nRT log V final by V initial, right? So this is the formula to calculate the work done during reversible process, and this is for expansion, reversible expansion, reversible expansion. Okay, If you convert natural log into log base 10, then you multiply it. Okay. So work done reversible is equal to minus 2.303 nRT log V final by V initial. Okay, log base 10. This will be log base 10. Okay. So this is for expansion. And we know that according to Boyle's law, V final by V initial is equal to P initial by P final. So the same formula can be written as, in the terms of pressure, we can write this same formula, that is work done reversible is equal to minus nRT log P initial by P final. Okay. So this is in the terms of what? Volume. And this expression is in the terms of pressure. Right? Then if you want to write for compression, you know that compression work is positive. During compression, work done is taken as a positive. Compression means work done on the system. Then what formula will you write? W is equal to nRT log V initial by V final. This will be the formula. Okay. So during compression, initial volume, see, during compression, so this is for compression formula. During compression, V initial will be greater than V final. V initial is greater than V final. Okay. So V initial greater than V final, log V initial by V final will be positive, and this is positive. So these quantities are all positive. N is positive, R is positive. So total will be positive. Understood? Next, work done for compression in the terms of pressure, if you write nRT, okay, log P final by P initial. During compression, final pressure will be greater than initial pressure. So during compression, what happens? During compression, final pressure will be greater than initial pressure. When you are compressing a particular gas, final pressure will be greater than initial pressure. So log more by less gives you positive value. Positive into this positive gives you positive. So compression work is positive and expansion work is negative. So that is about the formula which are used to calculate work done during reversible process. What is that? Reversible process. Right? Next, the same irreversible process. Isothermal, irreversible, isothermal process we are speaking. Irreversible isothermal process. In this irreversible isothermal process, irreversible process means the process in which the process cannot be reversed by reversing a small change. Say for example, let us keep some 100 grams mass here. 100 grams mass. Suddenly this piston moves up to here and stops. Piston moves up to here and stops, right? Initially the piston is here, so the volume is this much, V initial. When 100 grams is placed, it has moved from here to here. Now the volume is final volume. Volume is decreased. If you bring a small reverse change to this, if you reverse the change, the process cannot be reversed. So how to understand this irreversible process? Irreversible process means, for the process, if you bring small reversible change, if the process cannot be reversed exactly, then we say that it is a irreversible process. In this irreversible isothermal process, this process occurs very fast, Okay, it occurs in finite steps. It occurs in finite steps. So here we have seen only this process occurring in a single step. So it can also occur in finite steps, 1, 2, 3, in that way. Right? Then if you draw a graph for this, see at pressure P, this is volume V1, it is converted into volume, what is that, V2 at pressure P1. So this is one step, and with pressure P2, the volume is changed to V3 with pressure what, P2. With pressure P3, the volume is changed from V3 to V4. In this way, with pressure P4, the volume is changed from V4 to V5. So what is this? This is all expansion. What is this? Expansion. Because volume is increasing, the pressure is decreasing. Okay. So now, in how many steps the reaction has happened? The process has happened 1, 2, 3, 4 steps. Okay. In 4 steps, this process has occurred in finite steps, not infinite steps, finite steps. So if you draw a graph, then what graph you obtain? You get a rectangular hyperbola. When you draw a graph, you get a rectangular hyperbola. So this is irreversible isothermal process, irreversible process. So when do we say that it is isothermal? When delta T is equal to 0, then we say that it is a isothermal process, right? Next, coming to irreversible isothermal process. For example, it is taking in a single step. Okay. In a single step, initially the volume is V initial, and finally the volume has become V final, right? Then what will be this work done? Work done in irreversible process is equal to mechanical work done minus P external into V final minus V initial. So this is the formula to calculate the work done during irreversible process. Okay. If it is happening in more than one step, for example, it is happening in 3 steps. 3 steps which are finite steps. What is that? It's happening in 3 finite steps. So work done in the first step is W1, work done in second step is W2, and work done in third step is W3. The total work done will be simply adding those W1 plus W2 plus W3. That's it. Okay. So this is how we calculate the work done during irreversible process. Whereas when you draw a graph for reversible process, reversible process, reversible isothermal process or reversible process. Here reversible process, see, it is happening in infinite steps. Infinite steps. See, pressure, at the small pressure, a small change in the value. A small change in the value. See, very small change in the value. Change in the value. There is the pressure. Next, pressure is changing and a very small change in the value. Again, see, let us very small change. We know that a reversible process is an hypothetical process, ideal process. Okay, not practically possible. Again, with some less pressure, small change in the value, small change in the value. So in this way, the process is happening in how many steps? Infinite steps. It is happening in infinite steps, right? In this way. Infinite steps, right? And these, every step is due to a very small infinite change in the pressure. Due to infinite change in the pressure, there will be infinite change in the volume. Infinite change in the volume. And if you draw a graph, again we get the same rectangular hyperbola. Okay. Same rectangular hyperbola. Same rectangular hyperbola will be okay. But when you compare these two, work done during reversible process will be greater than work done during irreversible process. Work done in reversible process will be maximum, and this is applicable for compression. What is that? Compression. When coming to, this is applicable for what? Work done reversible will be greater than work done irreversible for what? This is applicable for expansion. What is that? Expansion. Work done irreversible will be greater than work done reversible for what is that? Compression. Right? So let us see that. Reversible. So let us consider expansion. If you see this expansion, work done reversible is equal to minus P external into dV. Okay. During expansion, P external is equal to P pressure of the gas minus dP. Okay. Pressure exerted by gas is greater than pressure of the gas is greater than external pressure by infinite amount. Infinite means very small. That means Pressure of the gas and external pressure are almost equal. Are almost equal. For example, let us take here. Okay. External pressure is something like 759 mm of Hg, whereas this is external, and let us take this as 760 mm of Hg. What is this pressure of the gas? So pressure of the gas greater than external pressure, but it's very small, minute. These two are almost same. Okay, so this what we are speaking about here, reversible. Then speaking about irreversible, work done irreversible is equal to minus P external into delta V. Okay, P external, right? Here P external is equal to pressure of the gas minus delta P, finite amount of pressure, So let us consider between these two. Okay. We can also write dV if it is very smaller, or delta V, doesn't matter. Okay. The same V initial to V final, let us take. Now for the purpose of comparison, it will be easy. Okay. So external pressure is same. External pressure is very much smaller than internal pressure. So let us take internal pressure. Pressure of the gas is 760. 760 same pre-external plus internal. This is what this is pressure of the gas. See, what is this? Pressure of the gas. Pressure of the gas. Pressure of the gas is much greater than that of external. So P external now will be, for example, 740 mm. 740 mm. So now you know work done is equal to, okay, P initial to V final. Formula to calculate work done is equal to minus P external into dV. So it depends upon P external. This minus represents that it is expansion. Okay. Now you say external. Whose external pressure is more? In reversible process, external pressure is more. Whereas irreversible process, external pressure is less. That is the reason why during expansion, work done in reversible process is greater than work done in irreversible process. Understood? Okay. Now coming to compression. Same reversible. Let us consider a reversible process. Reversible process again, work reversible is equal to V initial to V final minus P external into dV. Okay. During compression, P external is equal to pressure of the gas. See, this is compression. Compression means what happens? P external will be greater plus dP. That means P external is almost equal to pressure of the gas. Okay. So when you take a gas, let us take P external is equal to something like 760. P internal will be less. Pressure of the gas will be equal to something like 759 mm of Hg. Coming to irreversible process. Irreversible process. Coming to irreversible process, again work done is equal to V initial to V final minus P external into dV. This can be used. See, P external is equal to P internal irreversible process. Okay. Plus delta P, finite amount of pressure. Finite amount of pressure. Now P external and P internal are differing more. So now let us take this gas. Now you see P external, P internal, let it be 759 mm. 759 mm of, but will it be 760 external? P external will be something like 780 mm more. So formula to calculate work done is equal to already we know that P external into dV, more external pressure, more amount of work done. In which external pressure is more? Irreversible external pressure is more, 780. Here it is only 760. So work done during irreversible process, irreversible compression is greater than work done during reversible. This is applicable for home compression. So these two things you need to remember. These two things are asked in the examination. What are those? Work done during reversible process. Work done during reversible process is greater than work done during irreversible process in expansion, whereas compression it is opposite. Work done in irreversible process is greater than work done in reversible process. Hope so you understood the isothermal process and work done in isothermal process, reversible and irreversible. Thank you for watching up to the end of the video. If you like this video, like, share and subscribe. Thank you very much.